Hello, my name is Kate Kraus. As part of my Learning Technology by Design course at Michigan State University, I've been exploring solutions to a problem with my current teaching practice using the Stanford Model of Design Thinking. To give a bit of background on my problem of practice, I'm a 9th grade pre-AP biology teacher at a large public high school in Manassas, Virginia. Recently, I've noticed that my current evolution unit does not focus on the development of critical thinking skills. Instead, this unit consists of mostly fill-in-the-blank notes and simple worksheets designed to be completed quickly before our end-of-year state assessments. To address this problem of practice and devise effective solutions, I have employed the Stanford Model of Design Thinking, which consists of 5 stages: empathize, define, ideate, prototype, and test. In the empathize, define, and ideate stages, I sought to better understand my students' needs, to clearly define my problem, and to brainstorm a broad range of possible solutions. In the prototype stage, I developed an example of a concrete solution to my problem. Finally, in the test stage, I implemented my prototype with my 9th grade students. My prototype consisted of a critical thinking lesson focusing on 2 learning objectives. Learning objective number 1 states that students can analyze data from a population of organisms to identify patterns. Learning objective 2 states that students can apply Darwin's theory of natural selection to explain these patterns. My prototype lesson was broken down into 3 portions: the explore portion, the sample data portion, and the new data portion. In the explore portion, students investigated the meanings of the terms analyze and apply from the learning objectives. In the sample data portion, we analyzed a set of data as a class and applied Darwin's theory to explain this data. After modeling analysis and application in the sample data portion, students worked in groups to use these skills again with a new data set and write explanatory paragraphs to showcase their mastery of the learning objectives. We conducted a peer review of the explanatory paragraphs, and students had the opportunity to revise their paragraphs based on the feedback they received. When I tested this prototype with both my 9th grade biology classes, it took about 90 minutes spread across 2 class periods. While I was implementing the lesson, I recorded observations of my students, facilitated class discussions to better understand student thought processes, and asked follow-up questions to gather student feedback. From the testing stage, I learned that students found the explore portion of the lesson to be very helpful in understanding the learning objectives. In the future, I think it may be helpful to show them Bloom's whole taxonomy so that they have lower level thinking skills to contrast with the upper level thinking skills of application and analysis. With regard to the sample data portion of the lesson, students stated that completing this portion as a class helped them to better understand the expectations for the new data portion of the lesson. Reading through the students' paragraphs from the new data portion of the lesson, I found that most students demonstrated clear mastery of the learning objectives. They did, however, indicate that they felt the peer review was unnecessary, so I may remove this component in the future. Moving forward, I plan to design more critical thinking lessons for my evolution unit that focus on the same analysis and application skills but different concepts. In these lessons, I may be able to remove the explore and sample data portions to save time because we've already investigated what analyze and apply mean and modeled how to use these skills in the prototype lesson. Overall, after the testing stage, I recognize how important it is to have a clear testing protocol. If I had not determined how I was going to evaluate my prototype before implementing it, I would not have gathered such helpful results for the revision process. Additionally, I found that I had to shift my mentality a bit to understand that the initial prototype in any design process is never perfect, and that significant changes must be made to make the prototype an effective solution to the problem of practice. Thank you very much.